Okay, first of all, what is big data? So I think you might have heard about that. What is big data and all? Big data means a large volume of data.
Mhm.
The raw numbers is big. It's more than a million, more than nearly billion or trillion records are there at the source system, and we need to load the data into our target. So as we know, the data flow from source to target that can be done by the ETL tool, extract, transform, load.
Mhm.
Okay. And if we do the same data transfer by ETL tool, the conventional ETL tool take lots of time to load the data from source system to target. So that is why big data processing is, nowadays we are following this thing in our ETL process. Okay. So what it's actually doing? So it's processing the data parallelly. So let me tell you. So suppose 1 million of records are there. If we have a single ETL source, ETL tool over there, we are processing, suppose 10 records or suppose 1,000 records per second. Okay. But if we are parallel processing means multiple nodes are working over here parallelly. Suppose there are 20 nodes and there are 40 nodes are working parallelly. So if this is the scenario, for ETL, 1,000 rows has been processed by a second. Over here, 1,000 into 10 rows will be processed per second. We are imposing more than one computing engines. Okay, so that is the concept of big data. A particular master node is watching all the task nodes, and task nodes are working parallelly. Okay, so when their work is completed, they can submit the output to the master node. So, Hadoop is one of the example of the big data. The main concept of big data is distributed. The main keyword, we are distributing the thing among various nodes. Okay, so Hadoop is one of the big data platform. So we can say Hadoop is open source software platform. The main keyword I told, distributed storage. So we are using some storage area. So there also we are storing the files in distributed in nature. So there is lots of nodes available. So we are dividing the large file into small blocks, and those are being stored into various storages. So even for storage purpose or to fetch data from that storage files, it should be much more easier. Okay. Distributed storage as well as distributed processing. For any kind of process of data, Hadoop will not do the same thing by a single machine. Hadoop clusters had multiple machines. So in yesterday's classes, we have gone through the EMR cluster. EMR is one of the component in AWS. So EMR consists of multiple computers, multiple servers. Okay. So multiple servers means we have lots of task node available. So that's why each task node will do its own work. So it's distributed storage as well as distributed processing. That is why the things are Hadoop. Hadoop is doing its work very fast. Okay. You can see by the comparison, it can solve the issue or it can flow the data 100 times faster than that of a conventional ETL tool. Okay. So what is Hadoop's architecture? Let me show you the bigger diagram. If there is any stuck point or anything, please tell me. Okay.
Sure.
So this is called Hadoop ecosystems overview or structure. So from this pictorial diagram, this below 3 blocks, it's Hadoop's own, inbuilt architecture of Hadoop. At the below is HDFS. that is called Hadoop distributed file system. On top of that, there is Yarn. Yarn is yet another resource negotiator. Resource means how many resources will work there. Okay, so it will determine how many nodes will be involved to do a particular distribution of processing. HDFS, this is Hadoop distributed file systems. This will store the data, store a big file into multiple chunks, and it will distribute those chunks of files into distributed file system. I mean, it will store in various nodes. Okay, so that to save a particular file, it should be much easier, or to read the data from the file, it should be also much easier.
Mm.
And on top of that, we have MapReduce, which is doing its work for big data purpose. Map, it's have two different things. One is called map, another one is called reduce. Map is mapping the particular work between various nodes, and they will transform the data accordingly. Reduce, what reduce will be doing? Reduce will be just taking the aggregations or taking the output from the calculations of multiple nodes what we have given during map or transformation operation. Just like aggregation, during aggregation we are grouping by the thing, so you can see the row number should be limited while we are grouping. So doing aggregation, the things are getting aggregated, the row numbers are limited, they may be summed up, they may be, we can do in the average and all. So MapReduce is doing the calculation and giving the output with proper distributed manner. Okay, so this is the basic backbone of Hadoop. With Hadoop, we have lots of add-on services available nowadays. So those are each add-on services, but you can see the particular one, each of the building blocks, those are starting from here. Some particular building blocks are coming to this position. Some particular building blocks, they're coming to this position. Okay, something is there only into this position. This is not just a design, this is that particular thing is has a functionality as well to design in such manner. Why? Just like if we tell for suppose Spark, we'll be learning Spark details from tomorrow onwards. So when using Spark, Spark is an add-on service of Hadoop. It is using HDFS from Hadoop. Okay, and it has its own configuration of Yarn and MapReduce inside Spark. So Spark is not using MapReduce and Yarn, it is only using HDFS. If we just run any big data processing stuffs by Spark, Spark doesn't, I mean, Spark will follow the HDFS from Hadoop, and it is having its own Yarn clusters. I mean, Yarn, that means resource negotiator part. It is having its own MapReduce thing. It's also having its own. Same thing is for Mesos and HBase. But for Tej over here, Tej is also Tej is hiring the HDFS and Yarn from Hadoop, basic stuff, and Tej is only having the MapReduce. I mean, it will be having inbuilt MapReduce within itself. Pig Hive, I think you might have heard about that one. Both of them are using all of the three. Yeah, you're telling something.
No, nothing.
Okay, so Pig and Hive, you might have heard about this too. Those are mainly query engines. So it's taking all the advantages from Hadoop. On top of that, it is having their own query engine. So we can do queries. I mean the SQL queries and all on top of those tools. Okay.
But
Apart from yeah,
I have a doubt. So, Hive is a Hadoop product, right?
those are yes, all of them are tagged with Hadoop, but Hadoop's basic building blocks is these three only, and those are add-on services. If we
Okay, so
skip Hive,
Hive is like database, right?
yeah, Hive is like
All
a
these are
database, correct.
database.
No, all of them are not database. Database can be there.
Okay.
Yeah, each base, the database, a particular database is with, assigned to it. Some existing database have been assigned to it with query engine. We can do select query. So maybe
Mhm.
Hive, we do not have a particular database, but we can query. The query engine must be there because we can do select query on top of HDFS by Hive. So what data has been processed till MapReduce, we can check Hive database. Yeah, Hive, there is a query engine as well as we can say a database storage is also been available there. Okay, or we can directly do the query part on top of HDFS file system. The files are stored in multiple blocks, and we can check what are the things are being stored by select queries and all by Hive as well. Similar kind of things for Peak too. Okay, for Hive we have database. You are correct. If you can use the Hue, do you have experience on top of Hive?
No. I've heard it because it's my friend works on Hive and he works for Facebook. That Hive is a Facebook product, right? So that's how I know.
Okay.
I mean, it was developed by Facebook and then it moved to Apache Hadoop.
Yeah, that historical information actually I also do not have for Hive. It has been introduced by Facebook. Later, it's been moved to Apache. Yeah, might be the reason. Might be the case. Yeah, definitely. I'm not sure for that one, but yeah. So Hive on top of that thing, we can have an existing database. We cannot as well. Without
Mm.
Hive, also Hadoop can work, but definitely it is having some query engines. And definitely, we are also using some databases as well, and that can be accessible by some portal called Hue. So we can directly do the queries in the portal, which is connecting to the HDFS and MapReduce and all. So those query-based tools are also required because we are storing something over here, but we do not have the relational database to check the data, whatever we are doing over here. So that is why those things are required. Okay. From Spark as well, we have Spark SQL. Okay, to check the SQL stuffs on top of this HDFS, yarn or MapReduce or the inside yarn in Spark. So basically, I tried to say this particular things which is been starting over here for Tej is only using yarn and HDFS. Pig is using both of the three. All of the three. Hive is also using all of the three. So this is the entire concept. Uzi is a uh, it's called scheduler. Okay, we are creating jobs over here. Uji, we can use Uji as a job scheduler. Okay, just like
Mm.
if you are aware of Windows scheduler, in Windows, if we
Mm.
create some batch scripts, we can schedule the batch scripts to be run for a particular day, a
Ah,
particular time in a day. Similarly, in
yeah.
Linux server, we have cron tab. Cron tab is a scheduler. If we create some shell script in Linux server, we can schedule those Linux script for a particular time in a day to be done or to be executed. Similar kind of, inbuilt Hadoop ecosystem, there is a scheduler called Uzi. Okay. Zookeeper is there. Zookeeper will be helping to check whether the yarn is working properly or not. Yarn is generally been assigned for resource negotiator. If sometimes it doesn't work properly or anything happens to it, so Zookeeper is responsible to fix it. Okay. So as per the diagram over here, it's been used for monitoring purpose. Okay, whether the task nodes are working properly, whether master node is monitoring the task nodes and all. Okay,
Mhm.
Scoop is also a different, a tool we are using Hadoop architecture. You might have heard about Scoop. So it's having its
Mm-hmm.
own file, I mean, a distributed file system, Yarn, MapReduce within itself. And on top of that, we have Apache Ambari. This is the entry point to all the Hadoop ecosystem. Apache Ambari, it can be a portal. Okay. If you install the Hadoop ecosystem in your system, so in your local, we can open this thing by portals as well to check whether how many nodes are working now, what is the status of Hadoop, I mean, how the jobs are running, if there is any stuck points or anything, any stuck nodes are there. So Apache Ember is nothing but a UI, and by this UI, we can check the status of the component. Okay, it's just for viewing how they are working. Okay, what are the present status and all. It's called Apache Ember. It's the, I mean, just entry point from us to the Hadoop. We'll be checking everything by Apache Ember and check the present status of each component which we have deployed. Okay, so this is the concept of entire Hadoop ecosystem. Going to the next. Yes. So as I mentioned, there are lots of query engines available, just like Hue, Presto, Phoenix, Apache Drill. So query engine means the same thing I told, that we can do select query or any other query on top of Hadoop systems. So just like you mentioned that we have internal data storage of Hadoop, just like Pig, Hive. So we have some external databases, external data storages as well. Just like MySQL, we have already covered this thing in our local systems. We covered this thing as a database. So Hadoop has the capability to connect with some external database storages as well. Suppose maybe the requirement may come that I do not want to use Hive to store the data which is being generated from here. I want a separate external database because Hive is very slow. So then we can use any external databases and we can integrate the database with Hadoop ecosystem. Those kind of external database you can use MySQL, Cassandra, MongoDB. MySQL is a relational database. MongoDB is a non-relational database. So anything we can use for our purpose. Okay. So moving to some more details in top of core of Hadoop. Core means that I mentioned already. HDFS, Yarn, MapReduce. So over here, just my plan is to cover up the core of the Hadoop. Core means these three. Okay. The concept of these three actually as a Hadoop developer and all, I'm just giving you the knowledge of architecture, but as a developer, no need to add of this stuff. You can see lots of things they are doing. So this is inbuilt architecture. Suppose one node failed in middle while doing the computing process and all. We should not have to take care of it. We should not have to check which particular node to be assigned and all. So they have the internal architecture set up. During runtime, they can start up any node. They can fail. I mean, from a failover, they can start any nodes or they can keep idle any node as well. So Hadoop has the capability to do the inbuilt transitions and all. So as a developer perspective, we can do coding part. So for the developer perspective, I'll be covering Spark from tomorrow onwards. What we need to do actually, what kind of codes are being useful over here. So we are writing the codes and code are being executed over here, but the architectural works and all, those are everything can be maintained the inbuilt Hadoop. Okay. So moving to the same slide again. Code of the Hadoop. Code is consists of HDFS, Yarn, MapReduce. Just I'm introducing one by one. What are the things? I already just give a brief idea. So today's thing is just we will be covering the core things. So HDFS, Hadoop Distributed File Systems. So as I mentioned, this will break large files into small chunks or small blocks, and it will help to distribute the storage of big data across our clusters of computers. So we are not storing the big file there. We are using the HDFS, that means distributed file systems, and we are storing this file into small chunks so that while retrieving the data from the file, it should be much more faster. We'll get output from each of the node, and the thing should be parallelly processed. So that is why HDFS come into the picture. YARN means yet another resource negotiator. It will manage the resource in the computing clusters. So as I mentioned, computing clusters it should be consisting multiple computers nodes. Okay. So inside that there may be few task nodes, there can be master nodes. So YARN will negotiate how many resources will be there to do a particular processing. Okay. So how many core nodes, how many task nodes should be there, how many master nodes should be there. Generally, master node should be, single master node should be there, and it will control all the task nodes. Okay, I'll be coming to this picture quickly. Yes, the thing that I was mentioning earlier. So we have single name node. It's also master. We can also call it master node. And there are data nodes. Various data nodes are there. We can also call them task nodes. So generally, the parallelized work can be that the particular processing what we are doing parallelly, that can be processed between data nodes, and that can be controlled by name node. Okay. So a single name node is having all the metadata related information stored of each of the data nodes. Okay, so this is the concept. The single name node keep track of multiple data nodes. Okay, so it is having all the metadata related information. The particular data nodes, IP addresses, this thing, what kind of which block is being stored in which data nodes and all, which particular things is being processed by which data node. This is the thing. So suppose I want to take or read some data from a HDFS. So I am just entering the HDFS by a client node. Okay. So the internal communication should be, I'll be asking for particular file. I'll be asking from name node first. I'll be asking from name node first for that particular data. Name node will be helping us. The particular data is being stored in which data node. Okay. Then I can fetch the data from data node itself. Similar way, for writing a file, I need to get confirmation which particular things is being stored in which location from name node. And after getting the thing, we can search or fetch the data from data node. Okay. The thing is processing parallelly. We are not fetching all the entire files from a single go there. So that is why it's distributed in nature. It's processing parallelly. And one more advantage is there. I'll be coming to this topic. So suppose I have stored one chunk of files has been stored over here. This is not the entire thing. So the same chunk of file is being stored in another data node for archiving purpose or for taking backup purpose. So if somehow anything happened to that particular data node, maybe the data node got damaged and all, so we can retrieve the backup from another data node. So whatever memory or data is being stored in each of the data node, that is also stored as a backup into another data node. This is just for a disaster recovery architecture inside Hadoop. Okay. And what happens for the name node? If the name node goes down, it is also storing, we have also some backup for name node as well. I mentioned this thing. Name node writes the data into local disk and NFS. So this is the two things. Its name nodes data is also getting backed up. Okay. Now, how to check the data of HDFS? As I mentioned, there is a UI called Apache Ambari. Okay. So in which location, which block the data is getting stored and all. This information we can check it from Apache Ambari. There is lots of another things as well, I mean available as well, but this is the more common one. We can check the data by command line interface, HTTP or HDFS proxies, Java interface. I haven't used these things. I only use Apache Ambari till now. Command line interfaces as well. If we have Edge Linux node, then we can directly search for that. That is also possible. So, but those are various ways we can check the data from HDFS, Hadoop Distributed File System. Okay. Now the concept of MapReduce. So as we know, so we are taking data from source system, big data. As we are doing the parallel processing, so how MapReduce will help us over here? Map will map individual small data to individual nodes for the transformation purpose. Okay. Then when transformation is completed, we are reducing the nodes in this manner. We are doing aggregation. Maybe we are doing some summation group by something. Okay, we are doing summation. Summation means we need all the nodes data. We need all the nodes particular column value to do the summation. So we are not going this thing in a single go. So first of all, we are taking summation of two nodes data. We are keeping this thing in one stage. Then again, we are doing the reducing part in next stage. This way we are reducing the part. It can be done by multiple stages. 2-3 more stages reduce over here in a single step, or maybe reduce is over here in fourth step. Here 2 steps. Again, is last steps of reducing, and we are giving the output to the master node. So the final summation, that should be the return statement. Okay. So this is how the entire calculation can be done, which is distributed in nature. Map and reduce, and that will help us to solve the problem or any mathematical operation or anything, any processing steps should be distributed in nature. Okay. Any doubt till now?
So all these things we will be creating, right? Like as per the requirements.
No, we will not be
Like
creating anything.
uh
So when we'll be doing the jobs, I mean, when we'll be doing the programming part, what we have to do? We'll be just giving, suppose I need to read a file. Okay. I need to do some
mm,
transformation operation. I'll be writing this thing transformation or mapping part. We can do map operation or transform operation. While I'll be writing this particular command, it will be mapping. Suppose there is a database having thousands of records. So while doing the transformation cannot be done in a single go. It will map each of the maybe 10 records for one cluster. One nodes, 10 records for one nodes, 10 records for one nodes. It will be mapping the thing to do the transformation. Okay, each node stored each of the data set or row. Okay, 1000 rows can be divided by 10. So suppose we have 10 nodes available, 10 task node. So we can split the 1000 records into 100 records of 10 times. Each 100 records they will send, or they will map the information for transformation purpose to each nodes. Okay. After the transformation is completed, we can back the result directly from transformation. It's simple. You can do that thing. We can also do some aggregation function which will reduce the count and all and give us the final output. So that is why we are not doing in a single computers. We are doing the things in multiple computers. We are just writing the codes that we need to read a particular file. I'll be showing this thing in tomorrow's session. So they will be doing
Mm.
mapping part by transformation for doing some transformations and all, and then they'll reducing the part doing so many aggregations. So all those stuffs are being distributed in nature. That is the main fundamental stuffs. We are distributing the data. We are distributing the computing powers. On not only one computer will solve the problem, multiple computer will process at a single point of instance to solve our problem. So how many nodes are been over here? I just mentioned 10 nodes are been assigned over here. So we can see our, normal convention method is, the particular big data method is 10 times faster of normal convention method. Okay. So here is an
Okay.
example as well. Activities on map reduce. Mapper transform the data across computing cluster and reducers aggregate the data. So we have both map and reduce, and that thing should be working in this manner. Suppose I'll be doing some join operation. I just mentioned the join operation. In the back end, they will do the map and reduce part among different task nodes or data nodes, whatever you can say. So this is the concept. We do not have to map each work to each node. That that is the internal architecture they will do. We just have to write the command that we need the join. The similar kind of stuff. What we have done in Python. Okay, suppose we need joins between two data frames. We just have to write it down. They will be doing the mapping part for us, from us. They will be just taking the command only and they will do the things in backend, assigning the work to multiple task nodes. This is the entire concept. Okay.
Okay. Okay.
So
I also have another doubt.
yeah.
The thing is, so we have like the companies will be having like millions of data stored, right?
Mhm.
It will be stored in the cloud based, right? Like now most of the companies are using cloud, right?
Yeah, they're using cloud.
So, okay, what if the data or the system crashes and the data is lost? So, will the data be still stored in the cloud?
Yeah. Yesterday, the day before yesterday, actually, we were discussing on same stuff. In cloud as well, they are having the disaster recovery planning. So
Mm-hmm.
suppose we are just taking help from AWS cloud. So while deploying a particular databases and all, you have to choose a particular region. Suppose you are choosing the data center of North Virginia. Okay. So you just
Mm-hmm.
launch a particular servers over there, you store data over there, and suddenly there are earthquake or any storm attacks in North Virginia over there, and the data centers data and everything got disrupted. So then what happens to the data? So this is the concept of cloud. Cloud will not store. Cloud will not store the data in a particular data centers only. It can also it will distribute the data in other data centers too, just for backup purpose. So if any disaster happens, it can retrieve the data from that backup systems. And the the backup part should not be in the same region. It is another point of world. Okay.
Okay. But
So
isn't that an extra cost for the company?
no, that can be an extra cost, but that thing should be their mind. This is an extra feature. Okay.
Okay.
So this is an extra feature. So that kind of problem, might have happened earlier. If we have on-premises databases, so if they're
Mm-hmm.
storing these things over there, suppose some actually in USA itself, suppose some storm, like I forgot the storm name, that particular,
Tornado?
yeah, tornado is there. A particular storm, Katrina or just like this, hits North
Mm-hmm.
America. Long years back, and lots. Data centers got damaged and all. Then they are not able to retrieve the data. So
Mm-hmm.
AWS systems we are giving, paying the things over there. while storing the records and all, but they have this inbuilt features. They can transfer the data quickly to another
Okay.
region which is not near to this region. So if anything happened to this region, the other region can be saved. But we do not have the
Okay,
information
understood.
in which region that thing is getting backed up. So it's internal calculation or internal logic. Some my data center is in North Virginia. So what is the backup path? I mean, what is the backup of this? I mean, if I'm doing something, where the backup is going to be stored? Okay, this is not in our knowledge. So that thing even we do not know.
Okay.
That is the internal things within the AWS. Okay.
Mm-hmm.
Okay. So today this is the main thing what we have learned. Tomorrow we'll be learning uh, the coding part. Why? What we have to do? We do not. I mean, what actually we need to do? I mean, for the programming purpose. As we already know, Python, especially pandas, it's almost same kind of stuffs. Even for Spark as well, it's maintaining some of the data. I mean, data structures within itself called RDD, data frames, and all. Data frames is the similar kind of data frames what we have used in Python, but the basic thing was RDD. So both of them will be covering in tomorrow's session. Okay,
Okay. So
and
all of these have separate environments for them. I mean, like the applications, like how the My Python or MySQL has the applications. Does each of them also have the same applications?
sorry, didn't get your proper question.
It's now Python has an application which we can download and do it, right? So
Correct.
is the same way. Do we have an applications for Hadoop, Spark,
Yeah,
for
yeah,
all
yeah.
these things?
Yeah, for Spark, we have, I mean, we can download the software
Mm-hmm.
and the same thing again. So we have the backup software of Hadoop, but we can access this thing by several softwares, for several IDs, just like Python. For Python, we choose PyCharm, but the backend thing was that particular Python interpreter. Okay, but we have chosen PyCharm to do the query. I mean, do the coding part and all. We can do the same thing in our command prompt into window as well. Similar kind of stuffs are there for Spark. Tomorrow I'll be generally I'll be showing to you how we can do
Mm-hmm.
this thing by command prompt. Spark has its own command windows and all, so we can show you
Okay.
how Spark can be doable and what is the open source tool,
Oh,
where to install it and all. Even for backend Spark, we do not have to install it. We have the installed file available in web. So as I told that for Spark, Spark is taking help of Hadoop, just like
mm-hmm.
HDFS. So not only you need to install Spark, with Spark, Hadoop version should be also coming. It should be integrated. And I'll be telling these things this thing tomorrow. And we'll be take this thing in your machine and we can start a bit small coding part. And the next day we can have some complex coding part. Next day means next week, most
Monday.
probably.
Mm-hmm. Okay, sure.
Okay. Okay. That's all for today. Let's connect tomorrow.
Yeah, okay. Thank you.
Thank you. Bye bye.
Bye.